Welcome friends, I am Jayesh Gandhi and today we are going to discuss the fourth tutorial in the series of digital electronics. In the last tutorial we have talked about the AND gate and the OR gate along with the Boolean identities relating to these two operations. Today we want to go ahead and talk about the NOT gate, and then we'll talk about two more gates which are very important for digital electronics. So let us start. So let us talk about the NOT gate. We have already known that the NOT gate, when the input is 0, the output becomes 1. When the input is 1, the output becomes 0. It is also called as the complement of the input. If we have two NOT gates cascaded with each other, cascaded means the output of one connected to the input of the next NOT gate. Then what happens is that A is the input. The first NOT gate will complement it and you will get A bar, and again the second NOT gate will complement it and you will get the A bar bar, and that is once again A. So A bar bar is equal to A. This is a very important identity of digital electronics. A bar bar is equal to A. Let us go ahead and use this NOT gate in conjunction with the AND gate and OR gate. So the next gate we want to study is called the NAND gate. The NAND gate word stands for not AND. It is a AND gate followed by a NOT gate. So what we have over here is an AND gate followed by a NOT gate. The output of AND gate is connected as input to the NOT gate. So A and B is the input. This is the AND operation, A dot B, and the output will be A dot B bar. When you combine such two gates and make one gate out of that, then this is called the NAND gate. This is called the NAND gate. It is AND followed by the NOT. The circuit symbol is same as AND gate, followed by the circle in the output, which is shown over here, this circle, and this circle indicates that the output is complemented. Let us look at the truth table. So if we take 0 and 0, the output is 0. Now this output is complemented once again, so you will get 1 as the output of the NAND operation. 0 and 1, the output is 0. This is 1. 1 and 0, the output is 0. This is 1. 1 and 1, the output is 1, and this is 0. So you get the NAND gate operation. This is one of the most important gate, or rather NAND gate and the next one, which is NOR gate. These are the most important gates which are used in digital electronics. We'll see why they are important at a later stage. On the same line as NAND gate, we have an OR gate. OR gate followed by the NOT gate. So A and B are the inputs. The output is A plus B, that is A or B, and then it is complemented, so it is A or B bar. The circuit symbol for NOR gate is shown over here, and once again you find that the OR gate followed by this bubble makes the NOR gate. Let us see the truth table. 0 or 0, the OR operation is 0. The NOR operation is 1. 0 and 1, the OR operation is 1. The NOR operation is 0. 1 0, it is 1, and this is 0. 1 1, it is 1, and this becomes 0. So that is the truth table for the NOR gate. So that brings us to the end of this tutorial. Today we have talked about the NOT gate, NAND gate and the NOR gate. Next time we are going to talk about an interesting theorem. So I request you to subscribe to my channel and hit the bell icon so that you get the notification for that. And please support our channel and like our tutorials. Thank you very much.